Okay, this one should be really quick. We're just going to do the tangent vector. This is under the same unit as vector valued functions. Essentially, all we're trying to figure out here is if I have some space curve and I want to know at any instantaneous point, just like we're used to with derivatives, what is the tangent vector to that point? Okay, so that's what I want to know. There we go. So to find that, we're still using the concept of derivatives, but we just have this special relationship here that I've already written out. So what this says is we need to take the derivative of our vector value function, and then we need to divide it by its magnitude. So all that really means is we're just like normal finding our tangent line, but we want to make sure to divide it by its magnitude to get it to where it is just a direction, but it does not change the value of anything we multiply it by. Sneak peek for later, right? We're going to do stuff with that. But for now, we're just going to deal with this quick little formula. So we're going to do that on this vector valued function I've already written out. So we've got r of t here. So we're going to go straight to r prime of t. Remember, we're only taking the derivative of each component in this case because we're not doing anything special. There's no product rules, nothing crazy here. So just derivative of cosine is going to be negative sine of t. And that's still I hat. That doesn't change. And the derivative of sine is positive cosine of t. And that's still j hat. That doesn't change. Now, flashback to a couple videos ago where we took the magnitude of just any vector. It works the same here. So we're going to take the square root of the square of every component added together. Technically, there should be a negative here, sorry. Okay, so when I take all of this and I put it together, I'm going to get the square root of sine squared of t plus cosine squared of t, which hopefully that looks super familiar for everybody, because then we'll notice we just have the square root of 1, which is 1. So in this case, our magnitude is just 1. So this one's not too crazy. So therefore, for the vector valued function, r of t is equal to cosine of t plus sine of t for our x and y components. Our tangent vector, our unit tangent vector, sorry, is going to be r prime, which is negative sine of t, comma, cosine of t, divided by the magnitude, which is just 1. And that's it. This concept's pretty straightforward. Practice it a couple times just to get used to it, because you can get some weird numbers in your square root, but that's really all there is to this part of it. Just understand the reason why we need to do this magnitude is to make it to where this is a unit vector here. So we aren't changing the magnitude of anything we multiply this directional vector to, just as a little sneak peek to the future.